Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 7, Lesson number 2, on reflecting parabolas, and more generally, on reflecting functions. All right, we're just going to use parabolas to mainly illustrate the point, but we're going to be reflecting functions all over the place. Specifically, we're going to be looking at how we can create functions, or the formulas for functions, after they've been reflected across both the x-axis and the y-axis. All right, so let's jump into an immediate exercise. Make sure you have your TI graphing calculators handy. All right, so in exercise 1, we've got the parabola f of x equals x squared minus 6x plus 5 plotted. Just trust me, that's the correct plot. Letter A says, consider the function g of x equals negative f of x. Determine a formula for g and graph it on the grid below. And what we're going to be doing is we're going to be using the graphing calculators to generate a table of values, but we've got to create the formula to generate that table of values. So g of x is going to be negative f of x. All right, fair enough. But we can even create a better formula for it because, really, what does this say? It just says g of x is negative 1, really, times f of x being x squared minus 6x plus 5. So the formula for g is negative x squared plus 6x minus 5. All right, simple enough. Now what I'd like you to do is pause the video right now, put that formula into y1, generate a table of values, and plot them. All right, let's do it. Again, I'm not going to open up the calculator. It takes too much time. Hopefully you can look back at previous lessons if you're a little bit confused about how to create a table of values, but I'm sure you're probably good. So here we go. All right, we had 0, negative 5 on there. 1, 0 was on that graph. 2, 3. 3, 4. 4, 3. 5, 0. And 6, negative 5. So we get a graph that looks something like this. Let me label that as g of x. I think I'm going to label that first one, we'll put it in black, as f of x so that we just have it there. Okay. Now, letter B says, how is the graph of f, so the original one, transformed to produce the graph of g? Well, how would you describe that? Pause the video now if you need to. All right. F was reflected in the x-axis, right? So we just took f, we flipped it across the x-axis, and we got g. Some of you may have used this symbolism in geometry, little r for reflection. Unfortunately, some people have started to use big R for reflection, which is awfully confusing because big R was normally reserved for rotations, but what are you going to do? At the end of the day, f was reflected in the x-axis. Now let's consider something that's a little bit trickier. Letter C says, now consider the function h of x equals f of negative x. Determine a formula for h of x and graph it on the grid above. All right, fine. Let's do it. We'll do h of x all in blue. Well, h of x is f of negative x. Now, how do we figure out that? Well, wherever there's an x in the rule for f, we now have to put a negative x in, and we have to do whatever has been done to that negative x, or to the positive x, we now do the negative x. And we could actually put that into the calculator that way, but I'm going to simplify it a little bit. And this is the piece that might be confusing for people. Right? If we do negative x squared, we get negative x times negative x. Well, a negative times a negative is a positive, and x times x is x squared. Now we have a negative 6 times negative x, but that's a positive 6x and plus 5. So again, what I'd like you to do is pause the video now, create a table of values for that formula, and graph it. Okay? All right. Let's go through it. What I found, my first value was negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Negative 6, 5, I found was one value. Then my next value that I found was 5, negative 5, 0. 1, 2, 3, 4, 5. Negative 5, 0. Then I found negative 4, negative 3. Then I found negative 3, negative 4. Then I found negative 2, negative 3. Then I found negative 1, 0, and 0, 5. So I ended up with this lovely graph. And that's the graph of h of x. Now, how is the graph of f, the black one, transformed to produce the graph of h? Think about that for a second. All right. Well, as poorly as it was drawn, f was reflected across the y-axis to produce h of x. Now, neither one of these really should have been a surprise, and I want you to think about why that is. If you remember a little bit about reflections in the x and the y axis from geometry, right, what hopefully you remember is to reflect something in the x-axis, to have a reflection in the x-axis, what we end up doing is we end up negating the y value. But that's exactly what we're doing right here when we have negative f of x. We're negating the y value. F of x is the y. On the other hand, when we reflect in the y-axis, we end up negating the x value, which is what we did right here. That was pretty darn obvious, right? When I'm doing f of negative x, I am definitely negating that x value. So both of these patterns, thankfully, make sense given what we already have a feeling for from transformations in geometry. All right, pause the video now, think about this sum, and then we're going to summarize on the next sheet. All right, well, let me clear the text out and let me move on to the next page. Reflecting functions. So this is what we just looked at. When we have a function f of x and we negate it, it reflects it in the x-axis. So when we multiply the overall function, which is the y value, when we multiply the overall function by negative 1, it reflects it in the x-axis. On the other hand, when we negate the x value before we do anything else, then it reflects it in the y-axis, right? And we're going to get a little bit of a feeling for this with a very simple linear example right now. So let's take a look at an example with a linear function. Exercise 2 says, determine an equation for the linear function g of x equals 5x minus 7 after a reflection in the x-axis and the y-axis. So let's do it. Let's get an equation after we've reflected it in the x-axis. Let's get an equation after we reflect it in the y-axis. Well, for the x-axis, to reflect it, we have to negate the entire function. We have to take the entire function and we have to multiply it by negative 1. So that actually is pretty much it. But if you want to simplify this, we would get y equals negative 5x plus 7. On the other hand, if we're reflecting in the y-axis, what we have to do is we have to negate only the x value. All right, now again, that's a perfectly good way to leave it, but 5 times negative x would be negative 5x, and then that negative 7 stays the same. So it's not that hard to sort of apply these formulas in a very straightforward way, that kind of a problem. But let's see where we can take it from here. Pause the video now and write down anything you need to. Okay, let's clear out the text and keep going. All right, exercise 3. If a parabola has the equation f of x equals, etc., which of the following represents its equation after a reflection in the x-axis? So pause the video now and think about this a bit. See if you can come up with the answer. Okay, well, to reflect in the x-axis means that we have to multiply the entire function by -1. But if we do that, right, if we take that entire function and we multiply it by -1, then we'll get -2x squared plus 3x minus 8. And there it is. All right. Now, of course, one of the cool things is that, let's say you were challenging this problem on some kind of an assessment on which you had your graphing calculator. I would still suggest kind of working out the math like what we just did, but then if you had any doubt at all, you could place both of them into your calculator, y1, y2, graph, and you'd see that reflection. All right, pause the video now and write down anything you have to. Okay, moving on and up. Exercise 4. After a reflection in the y-axis now, the quadratic function, g of x equals blank, would have the equation what? So now we have a reflection in the y-axis. Again, pause the video and see if you understand how this works. All right, I think reflections in the y-axis are much more difficult because in this case what we have to form is we have to form the equation g of -x. It's easy enough to take a function and just multiply it by -1. That's what we do when we reflect in the x-axis. We just take the whole function, multiply by -1, boom, we're done. But here, what we have to do is everywhere there's an x, we need to put in a -x. Notice how I put it in parentheses, right? And then -x times -x will be positive x squared. -7 times -x will be positive 7x, and then nothing happens to that too. So there we go. And again, just like I mentioned in the last example, easily you can put in those two functions, the original and choice 3, graph them, and you'll see that reflection in the y-axis. All right, I'm going to clear out the text. Okay, now exercise 5. This is where it gets real. Just kidding, it's been real the whole time. Okay, exercise 5. Consider the function g of x equals -x squared plus 4. What two transformations have occurred to the graph of y equals x squared to produce the graph of g? Specify the transformations and the order in which they occurred. Note that there exists more than one correct answer. Graph on your calculator to verify. All right, so what did we do to this, which we should know all about, to produce this? All right, think about that. Take a moment. See if you can think about what two transformations we did and what order we did them in. All right, well, I like to think about order of operations here. If I was actually going to evaluate g, the first thing I would do, right, if I was going to evaluate, let's say, g of 7, right, think about this, right? The first thing I would do is I'd square it. I'd do this function. And here come the transformations. The next thing I would do is multiply that by -1. And that would be a reflection in the x-axis, right? And after I did that, I would then add 4, right? Which is a shift up of 4 units. Now it's got to be in that order. You can't shift it up and then reflect it. You'll have a totally different graph, right? What we're doing here, and you can verify this on your graphing calculator, is we're taking the function y equals x squared, which we should know everything about, including the fact that its turning point should be at the origin, not slightly above the origin. Then we're reflecting it across the x-axis in order to give me something like this. So this would be y equals -x squared. And then we're shifting that thing up 4 units. So we end up getting a parabola that looks like this. And again, I'm not going to do it right now, but I would encourage you to take your graphing calculator and simply just graph this. Make sure that it looks like that. Okay? Pause the video now and write down anything you need to. Okay. Let's take a look at the last problem. The graph of f of x is shown below on 2 grids. Sketch the graph of negative f of x and the graph of f of negative x. All right. One might almost say that this is kind of a type of exit ticket. There's nothing new being introduced here. I just want to see how you can handle this symbolically. All right. So pause the video now and finish the problem. Okay. Well, really, the reason I consider it sort of an exit ticket-like problem is that graph and label negative f of x, well, that's simple enough, right? This is going to be a reflection in the x-axis because we have multiplied the entire function by -1. So it's great. We can take each point, 1, 2, 3, 1, 2, 3, right? 1, 2, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Now we'll kind of speed it up a little bit. And we get this. And that's negative f of x. Right? On the other one here, where we negate the x before doing anything, that's going to be a reflection in the y-axis. Same idea, we could take this point, which is 1, 2, 3, 4, 5. Let me do this in red. And we could reflect it, 1, 2, 3, 4, 5. Take this point, which is 1, 2, 3, 4. 1, 2, 3, 4. This one, 1, 2, 3. 1, 2, 3. This one, 1, 2. 1, 2, 1, none at all, and here. Come on, best graph of the day. Best graph of the day. Oh, and that's y equals f of negative x. So there it's just an issue of identifying which of the reflections we have, and then taking every point on the curve and reflecting it, or at least all the obvious points. Okay. Pause the video now, write down anything you have to, and then we'll finish up the lesson. Okay, let's clear this out and finish it up. All right, so today we saw for the first time, really, how one goes about reflecting functions in both the x-axis and the y-axis. Okay, in order to reflect in the x-axis, we multiply the entire function by -1, which effectively negates all the y values. On the other hand, to reflect in the y-axis, we first multiply the input variable by by -1. In other words, we substitute in -x everywhere there was a x in the function's rule in order to produce its formula. All right, that seemed a little confusing. We'll get more work with this as the lessons go on. For now, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.